Hello everyone and welcome to another set of video lectures. This time we are not going to talk about what to do with data. We are rather going to talk about what the data mean. Why? Well, because we're going to answer questions through data. And the extent to which those answers are really anywhere near correct, informative, useful, meaningful, everything depends on our proper understanding of the data, where it comes from, how it was collected, for what purpose, what structure they have, and very long, etc. As you're going to see, this is a very long block of content, which just shows the critical importance of not just jumping right at the data, start crunching numbers without properly sitting down and thinking first, what is it that the data are and what we can actually do with it. Let's take a look. So if we take a look at the course again, we could make a very clear distinction between everything that goes after collecting data and everything that comes before. Most of the resources you're going to see on data analysis, they're going to focus on this part here, on actually analyzing data. So we have some data set already and we're just worried about what can we do with it. But it's very important, as we are going to see in this block, that we need to properly understand, again, where the data comes from, what was it collected for, in which manner, what are the limitations, what are the assumptions, what structure do we have in the data, etc. Everything that had to do with the methods we followed to design a study. And why do we need it? Well, if you are the person who is in charge of designing a study, making decisions as to what data are going to be collected, etc., then it's going to help you just design a better study. Simple as that. But if you are not part of the decision-making process of designing the study, and they just give you a data set, this is going to be useful for you because you're going to better understand the design choices that were made for collecting the data, for carrying out the research study. And in order to derive useful knowledge and insights from that data, you need to properly understand where the data comes from. So what the data represents, what was it collected for, what were the assumptions, limitations, etc. This is very important, again, if the data set is just given to you as is. And we have plenty of data sets nowadays, tons and tons of data, millions of numbers everywhere, just waiting for someone to pick them up and start analyzing and possibly coming up with some insights about how the world works, right? And the point is, we can't just start looking at data and not worry what the data is for or what the data really means. If we do it, it's actually what some people call data myopia, which is this state in which we just get a data set, we start looking at it, we don't look at anything else, and it's just data, 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 data. We start making claims from it, and it's actually completely ridiculous claims that, for lack of better understanding of the actual data, we just make. That's it. The point is how we analyze the data, what kind of analysis we can perform on the data, depend on us properly understanding the data, properly understanding what the data represents. Something very important is where does it come from? What decisions were made for collecting this data? We're going to see plenty of examples about it. And not only because we conduct studies or we analyze data from studies, but mostly because we consume them, either directly because we read an article, a research paper, a book, or something like that, or because we just take a look at the news and we see what is the understanding of our reporter about the research of a third person. So we are actually consuming research indirectly through reporters. And we're going to see that there are several cases in which they describe the experiments or the research in a certain way that does not really correspond with reality. So it's all about having valid conclusions, making valid conclusions based on reliable evidence. Does our research really address the question under study? That's the first question. And the second one is, how confident are we about our claims? If we want to put it in just one sentence, I like this one. Everyone is entitled to their own opinions, but not their own facts. And this block of the course is all about setting apart opinions from facts. We're going to see what are the different things that, make something an opinion or just a fact. So let me give you another example. In this picture, we have results from a study from a few years ago in which 29 different research groups, they were given data about the Premier League, which is the football or soccer league in England. And the data was about red cards. And they were asking the question, are referees more likely to show a red card to a black player or to a white player? So they collected data from I don't know how many years. They gave it to different research teams, and they just told them, analyze the data, try to answer this question, do whatever you feel is the best in terms of analysis, and tell us your results. And so every point here represents one result. The ones in green are, so to speak, the ones in which the researchers were very confident about the result. The ones in gray are the ones in which they were not very confident. And then the result is essentially along the vertical axis here. So points that tend to be around there are analyses that show that there were no difference between black and white people. Results that are around here show that referees were twice as likely to show a red card to a black player than to a white player. And then finally up to here, results that show that they were 3 times as likely to show it to a black player. And so we have, for example, a result over here claiming that they were 3 times as likely, and the researchers were fairly confident about it. Whereas in this case, they also conclude that, but they're not very confident. Most of the points you see are around here. Those were positive results. They are in green. The researchers were very confident about it. And they showed that referees were between equally likely or twice as likely to show a red card to black players. And then some others around here that were somewhere in between. So you see, these are just different people performing different analysis on the same data to answer the same research question, completely different results. So it's very important to properly understand what the data are and what kind of analysis we're going to perform on the data. So in this blog, we're going to consider 3 types of study: descriptive, correlational, and causal. A descriptive study is just one in which we are just interested in describing something that exists. Let's say I own a pizza place and I want to know what's the fuel consumption of the motorbike that the delivery person uses. Maybe there are new presidential elections coming up and I'm interested in knowing what is the vote intention of the citizens. When we talk about correlational study, we want to see what's the relationship between different things, between 2 or more variables. So for example, I might be interested in whether men buy more beer than women. Or maybe I'm interested in the relationship between the age of a child and the reading comprehension level. And finally, we might think about causal relationships. So what is causing what? For example, let's say we are interested in knowing whether a new educational program that we implemented at the university actually makes students achieve higher scores. Or maybe I work in a company, we have a website, and I'm interested in knowing whether a certain change in the interface of the website is going to make users click more often in a specific place that I'm interested in users clicking on. So these are the kind of studies that we might be interested in: descriptive, correlational, or causal. And in general, through this blog, we're going to look at the study in the following way. So there's a certain process that we are interested in, artificial or natural, whatever it is. And there are certain inputs to that process and certain outputs to that process. And we hypothesize that the process is determined by different factors or different factors that influence how the process works. So the question is, how is the process affected by the factors? Let me give you an example. Say we work on transportation, and what we are interested in is the process of people traveling home from work. So what is the input to such process? Well, people, right? And what is the output we're interested in? Well, maybe we're interested in the door-to-door time. So only in how long it takes for a person to go home from work. What are possible factors affecting this process? Well, first of all, the transportation mode, right? Whether they go by bike, train, tram, car, etc. So this is a possible study we might be interested in. Another example would be medical. Let's say we are studying different operations for a kidney stone. What is the process? Well, operating on a patient. The patient would be the input. The output could be, for instance, the recovery time. We're interested in knowing how long it takes for patients to recover. And what we are particularly interested in is their surgical procedure. Let's say there are multiple surgical procedures we could apply, and we could see what is the recovery time per surgical procedure. Of course, this process of operating on people and the outcome is going to depend on which specific procedure we employ. So if we look again to the course globally, what we're going to focus on in this block is this part here. Everything about designing a study and actually collecting data. Why? Because everything we do afterwards, in terms of modeling, gaining new insights about the data or about this process and communicating those insights, is going to be determined by our proper understanding of how the data are collected and how the study is designed. So this block is going to be separated in 3 parts. The first part is going to be more related to how we measure stuff. So variables and their relationships, third variable problems. We're going to talk about Simpson's paradox and inspection paradox, and then the specific levels of measurement. We're going to see that the nature of our variables and how we measure them is going to restrict our analytical capabilities on those variables. We'll talk about it. The second part is about sampling and actual research design. So we're going to talk about populations, samples, standard errors, different sources of variability in the outcome variables, and then we'll talk about research design, factorial designs, factors and their effects. And the third part is more about the analysis of data. We'll talk about statistical testing, and finally, we will cover validity and reliability. We're going to stop a little bit and talk more about it because those are probably the 2 most important concepts in this whole block, whether the conclusions we claim from a study are valid or not, and how confident are we about those conclusions.